Day 2, lesson 15, this would be substitution as well. If you noticed equations prior to this, one of your variables were already solved for, whether that be x or whether that be y. So one of your variables were already alone. In this next set of problems, you need to go ahead and transform one of these equations so you can use substitution. So I'm going to say that I need to get y alone here. So in order to do that, I'm just going to ahead transfer my equation over here. I need to subtract 7x minus 7x, drop down my negative y equals negative 7 plus 1, divide by negative 1 in order to get y alone. Y equals 7x minus 1. Now that you have y by itself, you can substitute this in for y in equation 2. So you have negative x plus in for y, well, here's y, and we know y equals 7x minus 1. 7x minus 1 equals negative 7. Combine my like terms. I need to add 1 to both sides to get it off that side. Negative x plus 7x is 6x. 1's cancel, and we have negative 6 over here. Get x by itself, and we find out x equals negative 1. Now, take negative 1 here, and you can actually substitute negative 1 into this equation that you figured out, or either of the ones at the top here. So you're able to choose which one you want to put it in for. I'm going to go ahead and just substitute into one of these original equations here. I'll say that I'll put it in for the equation on top there. So we have 7, the 7x minus y equals 1. Substitute in, we know x is negative 1 minus y equals 1. This is negative 7 minus y equals 1 plus 7 to both sides. And we get negative y equals 8. Now y is still not by itself, so we divide by negative 1. And we have y equals negative 8. So you have a solution. Your ordered pair, this is your point of intersection where these two lines intersect if they were graphed. And here's that point of intersection. It has one point of intersection there, therefore it would be consistent. Check out example 2 here, same situation. In this problem, actually, what you should do is put this, get x by itself. Figure out what x would be equal to. So you'd add 6y to both sides. And you'd have x equals 6y minus 20. That'd probably be the quickest way. But if you didn't see that, you can still go ahead and put the other equation in here. And this is what your other equation would look like. Well, let's say you decided to get maybe y or x by itself. So you'd subtract 8y from both sides. And you'd have 5x equals negative 8y minus 24. Get x alone, divide by 5. Divide by 5. We find out x equals negative 8/5 y minus 24/5. Now that you have x by itself, you take that equation, go ahead, substitute into that first equation. So in for x, here's x, here's x. We know x is equal to negative 8/5 y minus 24/5 minus 6y equals negative 20. Combine your like terms. Here's my like terms right there. When I add them together, I get negative 7 3/5 y. Negative 24/5 would drop down, equals negative 20. Add 24/5 to both sides. Drop down negative 7 3/5 y equals negative 20 plus 24/5 is negative 15 1/5. Go ahead and get y by itself, so divide by negative 7 3/5. And we have y by itself now, and we find out y equals 2. Take 2, substitute in one of your equations up there. So I'll go ahead and substitute in for maybe this first equation here. And I have x minus 6y equals negative 20. Substitute 2 in for y, so x minus 6, here's my substitution. And I have x minus 12 equals negative 20. Add 12 to both sides to get x alone. And we have x equals negative 8. So in this problem here, your solution, your point of intersection is negative 8, 2. That's where those would intersect. On to your last example here. In this last example, you need to actually write the two equations. Well, one equation, it says y is 10 less than x. So think of it as like a teeter-totter when you write an equation. If y is 10 less, y would be up here. It's less than x. Okay? So you need to balance this teeter-totter out. In order to balance this teeter-totter out, this being your equal sign, okay, and we know we need to use 10, well, in order to balance this out, you can add 10 to side y, so that balances that side out, so your teeter-totter would now look like that. Another way to do it, instead of adding 10 to that side, is you could also subtract 10 to x. When you subtract it, that would also balance it out. But since it says y is 10 less than x, I'm going to go ahead and subtract 10 from x. It really doesn't matter. So I'd have y equals x minus 10. That's one equation. You need to come up with the second equation. Well, your second equation is regarding this triangle here. We know that angle y, angle x, and 90 degrees, when you add all three of those together, all three of those angles, you're going to get 180 degrees. So here's my two equations. Now you can go ahead and use substitution. Well, what's nice about substitution here is we already know that y equals x minus 10. So here's y. That's where we're going to substitute. So we have x plus, in for y, well, we know y equals x minus 10. Finish off your equation. Plus 90 equals 180. Combine your like terms. 2x, combine them. Negative 10 and positive 90 are going to give us plus 80 equals 180 degrees. So get x by itself. Minus 80, minus 80. We have 2x equals 100. Get x alone. Well, divide by 2. Divide by 2. We find out x equals 50 degrees. It's an angle up there. So now you can take 50 degrees, substitute it in one of them above. Well, I'm going to substitute in here. I have y equals, in for x is 50, minus 10, and I figure out y is 40 degrees. Now you can always double check your answer. Here's your value, 50 degrees and 40 degrees. That's what your angles were. Now that is your solution if you were to graph them. If you check back up here and substitute in, we know that x here is 50 degrees. Here is 90 degrees. Y is 40 degrees. When you add those together, those interior degrees of a triangle, we should get 180. And when we do that, we actually do end up with 180. So it's just another way to double check your answer. This concludes lesson 15, substitution, day 2.